You're welcome to another video of the course F5 Big IP LTM. In this section we are going to start to configure HA or high availability in F5 Big IP devices, which brings redundancy and load balancing to your Big IP devices. In this section we will implement active standby version of HA, which brings redundancy, but in the next sections we will implement active version of HA, which brings both redundancy and load balancing. This is the topology of F5 Big IP HA solution that we will implement in this section. There are two Big IP devices with the name of Big IP 1 and Big IP 2, both connected to the internal network with the subnet 10.0/24, where pool member servers are also connected. Both Big IP devices are also connected to the external network with the subnet 20/24 for internet connectivity. They are also connected to the management network with the subnet 10/24 for management access, and finally to the HA network with the subnet 20/24 for configuration and connection synchronization between Big IP devices. In the previous sections we did not use HA interface, but it is required to implement Big IP HA solutions. Therefore, it is configured in this section. HA interface will be used to synchronize configuration between Big IP devices. Optionally, it can be used to replicate live connections between Big IP devices in a stateful HA solution. In all networks, the IP address of Big IP 1 is 181 in all networks, and the IP address of Big IP device 2 is 182. For the internal and external interfaces, which are also called data interfaces, we need to configure floating IP address. Floating IP address are the same in both Big IP devices, but are only active in the active Big IP device. Servers and devices that point to the Big IP as a gateway use floating IP address. If active Big IP device fails, the floating IP address is moved to the next active Big IP. Therefore, servers and devices that point to the Big IP as a gateway are not disrupted. To begin F5 Big IP HA configuration, we start with the VLANs and IP configuration to ensure it matches the topology. I've already configured internal and external VLANs. Let's also add the new HA VLAN, which is required in HA configuration. It must be added in both Big IP 1 and Big IP 2 devices. Interface 1.1 is internal VLAN. Interface 1.2 is in external VLAN, and now interface 1.3 is used for HA VLAN. This is also interface 1.3 on tag, add, and the name of HA, and finished. And we also configure in Big IP 2 VLAN. Internal and external VLAN are already configured in the interface 1.1 and 1.2. Now HA for interface 1.3, and then on tag, and then finished. Then we configure the IP address of the new HA interface according to the topology into the self IP, and then create for the HA interface with an IP address 20.181 for Big IP 1. This is also for the IP address, and the mask 255 3 times, and then 0. For port lockdown in HA interface, it is important to make sure that the TCP UDP port 4353 is open, which is used for configuration synchronization. We can use custom ports to add the port, allow custom, or allow custom include the default ports, or we use allow default just for simplicity, which include TCP UDP port 4353, and then finish. And we also configure for big IP2 in the section self IP, and then create 192 168 20 182. This is also the IP address and the mask, and we use VLAN HA, and for port lockdown we use allow default for the simplicity, but it's important to make sure that the port TCP UDP 4353 is open, and then finish. For internal and external data interfaces, also ensure that the port, at least the port UDP 1026 is open, which is used for failover detection. We can use again the custom ports to add the port, or we choose allow default just for the simplicity, which include the UDP port 1026. It is already true for the internal interface. For the external interface, I will change it to the allow default and then update. For the big IP2, I will check it again. For the internal connectivity, it's already allow default. That means UDP 1026 is open, which is in the list of allow default. But for the external interface, I've already allow none. Change it to allow default to make sure that failover also works in redundancy solution. This is the list of open ports when you choose allow default in port lockdown options. As you can see, both TCP UDP port 4353 and also UDP 1026 for network failover are open in default lockdown ports. Then we are ready to configure HA parameters for both big IP devices under device management, and then devices section, big IP1, and on the top properties, ensure that the device name big IP1.radioco.co.local and management IP address are already configured, or change the device name according to your design. Under config sync tab, specify the interface through which the configuration synchronization will occur. We choose always HA interface to be used for configuration synchronization, and then update. Under failover network tab, we specify the list of the interfaces for failover detection. Typically, we use all data and management interfaces except HA interface for failover detection, and then add first internal for UDP 1026 and repeat, and now for external port 1026, and then finally management address and port 1026. All three interfaces, data and management interfaces, are added in failover networks. And under mirroring tab, we specify the interface in which the live connection table will be replicated between big IP devices. We usually configure a dedicated interface for connection mirroring because large amounts of data usually needs to be transferred. HA interface is the second option that can be used for mirroring. We don't use any dedicated interface here. We choose HA as the first option and internal as the second option for connection mirroring. The same configuration must be added in Big IP device 2 in the device management device, and the device Big IP 2 in the config sync. We choose HA for configuration synchronization, and in failover network we add all data and management interfaces, including internal, external, and management interfaces. And finish. For HA it must be deleted. Only data and management interfaces are added in the failover network, and then in the mirroring, for the first option we choose HA, and for the second option we use internal as the first big IP. If you notice, still both big IP devices are in a stand-alone state, and it has not changed. In the next step, we configure device trust between big IP devices. It is enough to be done in one of the big IP devices. In the other device will be added automatically in the device management and device trust members. We add the management IP address and username and password to retrieve the device information of the second device. IP address 192.168.1.182, the username admin, and we also give the password and retrieve the device information, and we have to device certificate match, confirm the certificate, and this is the big IP2, and add device. After a few minutes, also big IP1 will be added automatically to the trust list of big IP2. We have to wait a few seconds. In the device trust, you see big IP2 is trusted to big IP1, and here also in device trust and device trust members, big IP1 is trusted to big IP2. Also notice that both devices are now in active state, online and then active state. To complete the process of HA configuration, in the next step we configure device group. Device group contains devices that can synchronize the configuration and also fail over to another device if one device fails. Up to 8 devices can be added to a device group under device management and then device group. We create a new device group and include both big IP devices in the device group. Create with the name of, for example, a device underline group 1, and the group type is both synchronization and failover, not only synchronization, and both big IP 1 and big IP 2 are included into the list of device group. In the sync type option offers the option to synchronize the configuration manually or automatically. For HA configuration, it is recommended to use manual synchronization at first. However, you can then change it later to automatic synchronization. So I will not change it, and manual with incremental or with a full sync, and then finish. Now we synchronize the configuration from big IP 1 to all other devices in device group here, which is only big IP 2. Now we can click over awaiting initial sync or under device management and then overview. You can synchronize configuration manually. For example, when I click awaiting initial sync, it goes to the device management and the overview. You can here synchronize the configuration manually, push the selected device configuration, that means the configuration of BIG-IP1, to all other devices into the group which is BIG-IP2, and then here we click sync. After configuration synchronization, BIG-IP devices must be actually in active standby and in sync state. We have to wait for a few seconds or a few minutes. Now devices are synced. Here on line standby in sync, and the second device BIG-IP2 is admin and login again. Now we see that BIG-IP2 is active and in sync. BIG-IP1 standby and in sync. In the next step, traffic group, we will check traffic group that is automatically created when you create a device group. What is F5 BIG-IP traffic group, and what is the relationship between traffic group and device group? Traffic group allows you to route a collection of traffic to a specific BIG-IP device in a device group. With multiple traffic group, we can route traffic from different applications to different BIG-IP devices in the same device group. This is exactly what we will implement in the F5 BIG-IP active HA configuration in the next sections. As we will see shortly, for each traffic group, a collection of floating IP address is assigned. Still, we didn't configure any floating IP address. For each traffic group, you can configure which device is preferred manually or based on HA score. You can assign an HA group to a traffic group. You can also configure HA load factor. All these concepts will be explained in the next sections. As you can see, we have traffic group automatically created in the BIG-IP1 and BIG-IP2, both devices. Traffic group, and all the configurations are the default configuration. In the next step, we configure internal and external floating self IP that will be shared by BIG-IP devices and assigned to the traffic group. Notice the floating IP addresses are assigned to the traffic group. These configurations are performed in one of the BIG-IP devices. The new changes are then synchronized with other BIG-IP devices in the device group. Based on device IP address in the section network and then self IP, the IP address 10.1 is configured for internal self IP 10.1, and IP address 2.180 is configured as external self IP. No ports need to be opened for self IP. Therefore, we select allow none option in the port lockdown field. Let's create for the internal. We choose the IP address 10.1 and also the name, and the mask is 255, and the for port lockdown we choose allow none. This is important. The floating IP address is assigned to the traffic group 1, and this is the floating IP address, not a fixed IP address, which float between both BIG-IP devices. This is for internal 10.1, and for the external 192, 168, 180. Not only the name but also the IP address and the mask and all alone none, and again traffic group floating, and finish. Again, the configuration needs to be synchronized from big IP1 to big IP2, changes pending. Again, we go to the device management and then overview. We change the configuration, we synchronize the configuration from big IP1 to all other devices in device group, which is only big IP2, and push the selected device configuration, big IP configuration, to the group, and then we choose the sync option. Now devices should be in active standby again, standby in sync, and here active in sync. To manually change the active HA device, connect to the device that is now active, which is big IP2, in the section device management, and then devices. Click on the device, which is big IP2. At the bottom of the page, there is a option force to a standby button. Clicking this button is expected to move the active device role to the next device in the device group, which is big IP1. Now big IP2 is a standby and big IP1 is active. That means the role of active and standby is changed between these two devices. In the final step, we shut down the active HA device, which is big IP1, to ensure that the active device is automatically moved to the next device. With PuTTY, I will connect to the big IP1 with IP address management IP address 181, and with a username and password, and then I will give the command shutdown -h now. Now the device is expected to be shut down in a few seconds. I'm not able to connect to the device big IP1 anymore, and big IP2 we see it is active and the state should be disconnected in a few seconds. As you see, the state has changed to the disconnected state.